Hello, everybody. In this method, we are going to see formal method of describing. As you can see, this probably I've got this syllabus. We are going to see something about this one, EBNF, and this one. These two things we are going to see in our class today. Chomsky was the first person who described context-free and regular expression. There are about four types of what you call grammar, but he concentrate or we are going to concentrate only on two. One is what you call review. One is we call it as contest free. The other one is regular expression. Combination contest free contains of tokens, which we have already seen. Regular expression, syntax, which we have already seen. This combination of all the got is PL. If you see globally, contest free grammar is this much and regular expression is this one. These are all tokens and these are all regular expression. If you see this anything about a grammar, there is a context tree which are tokens. Any language can have. Then normally in a language we use print statement and everything. Hardly we use a grammar or regular expression. Based on that one, we are going to see this one. This is what contest. This is what formal method of syntax, and Chomsky was the first person who discovered about four types, but we are going to see only two: contest free and regular. Contest free contains of tokens, and this contains of syntax. Combination of together we'll see in the PL. Now, Bosky normal form was the first person who discovered in 1960. 1960, John Bosco and Peter was the this one introduced the formal method syntax on a programming language or any simple language. It's a syntax. Uh, there are different type of syntax. They discovered one type of syntax which was used on basically designed for this purpose. Basic later on it was developed for it was modified for some other purposes. Different thing came up. One this notation used for context-free grammar. We'll see what do you mean by context-free grammar or something like that. But it is syntax on a grammar, any grammar, a part of syntax. What do you mean by syntax? In English language, you see there is a syntax which describes. In Hindi language, there are some different syntaxes. In Urdu language, there are some syntaxes. The way you describe the syntax, how you write the language, that how it describes. It describes the syntax on a language, any language or a computer language. We see a simple language they have used and they have defined a syntax. Bosky was the first one. Context-free grammar, identical. Now let's move. And it was discovered on meta language. What do you mean by meta language? Or it was discovered by basically it is used on meta language. Meta language, which is language which is already been known to us. The language which is determined with a series of valid, which already known and it is a valid for us. Determine whether series of characters are valid. A series of characters like any Urdu language which you take or Hindi language which you take a series of character. Yes, it is valid in that language. General form of statement, generate a format of statement. Yes, we can generate a format of statement. Plus, we can divide that statement into part, break down the statement into part. A meta language, a language which is already known or which is known before we determine the series of character on that language and we describe it is a valid or not. Then we generate the well form of statement on that one, and then we break down that statement into parts and we see that is working or not. This is what BNF deal with it. So let's deal with here. BNF is Bosky normal form, the syntax which already given to you. Symbol on a right hand, on a left hand side, we see a symbol which is a non-terminal. Let me go through this one. I'll select this one and I'll go for color. I'll go the weightage. I'll take this one, very big one. So this is a symbol which is on a non-terminal. On the right hand side, we have got tokens and lexema. Lexema which also contain expressions, tokens, and then which sequence of symbols are also available in that one. And these are all combination of we call it all together combination of terminal. So left hand side is non-terminal. On the right hand side, sequence of terminal, maybe terminal or non-terminal, maybe terminal or non-terminal. Okay, terminal or non-terminal. Maybe terminal or not. What do you mean by terminal or non-terminal? We are going to see in the next slide. Okay, go back to this one. This, what does this mean? This is slide which is given to here. Means it defines, it says. What does it mean? It defines. In a syntax which we have seen here, if you see this one, what is this? It defines. Non-terminal is defined by so and so. A non-terminal is defined by so and so. It defined. What does it mean? It describe. It describe means what? It meanings. It describe. It describe means what? The meaning of it. The meaning of it. Meaning of it. It describe are terminals which cannot be divided. Example: plus is equal to open flower bracket, close flower bracket, star, or if, while, do, int, double, float, a, comma. Non-terminals, example of non-terminals are statements, expression, a list of expression, words, statements, or something like that. If you see this one, an example, non-terminal is defined by what? A non-terminal statement is defined by what? A non-terminal statement. All right, non-terminal is a statement. Is, what the meaning of is? What is the meaning? Defined by. What does it mean here? Defined by. So is defined by what? Is defined by. Is defined by what? Then we say there are some of statements which contain expression. It also contains terminals or something like that. Okay. So on your left hand side, it is non-terminal which can be divided. On the right hand side, it contains. It can be divided. It cannot be divided. Terminals and non-terminals, and which is a part of it, tokens and lexema, which is called as expression or something like that. Okay. This is an example of this BNF. Now let's move on to other slide. Example here. On your left hand side, we have got how to write it. This is the rule which we accept in BNF. Non-terminal is equal to tokens and non-terminals, which I've told you before itself. It contains tokens and non-tokens, tokens and lexema, or tokens or non-terminals. So here, this one, or non-terminal is defined by tokens or non-tokens. Start symbol, we say that this is a start symbol which is defined by what are the start symbol? One or more terminal, one or more non-terminal. This is the syntax of it. This is what we call it as syntax. This is as syntax of it. Okay, this is a syntax for it. This is very important part for it. This is a syntax what we are going to write for this one, Bosky normal form. Now other example, we'll loop up. If loop. Now let's take example. If loop, we say this is what we call it as basically it's a non-terminal. So it has to come on the right hand side. How if loop is divided? If it has to come on the right hand side. How the if loop is executed? Let's take example. If control A, delete, cut. If loop. If I write if loop, if condition body of the loop, correct? If so, it should be on a right hand side. How it is defined? It should be on the left hand side. This should be on a LHS. Okay. How it is defined? It should be on a right hand side. It contains what? For loop I is equal to or something like that. Printf statement, token printf, which is a reserved words or something like that. Then semicolon, which is also symbol. The value of so and so is also. So the body of the loop contains so and so. So it contains token as well as non-terminal. Correct? Like A is equal to B, so and so. So this if comes on a left hand side, this condition should come on a right hand side. So let's move on to other one. This is here. So look, if part is if condition, body of the loop. If part, and this is coming on your right hand side. And then we'll see the other slide which is already there. This is very good example which we go on a net, which is very basic example which is given by any Pascal language. Let's see this here. Okay, Control X, Control A, cut. Let's take example. What was that? Begin. begin a is equal to b plus c, e is equal to d, e plus d, and y is equal to y plus 1, and this is basically written in Pascal language, same as C language, where you have flower bracket and close, open bracket and close bracket. This is a C language. We are not bothered about how A is defined, what is the value of A, what is E, or something like that. We only want to say A is equal to this one, and we call this one is your program. This is body, correct? Begin and end, body, and these are all statement. Okay, these are all statement in that body. We are going to see these are all statement in the body. So what are the statement? Let's take example. These are the statement. So program, begin and end. This is my body, correct? Now if the body contain, this is my statement, correct? If this is statement executed, let's take example. I'll take this one and this one. If this statement is executed, let's take example. I'll take the executed. What about this one? This is again body, first part. Now on the second time, I'll take this part. On the second time, I'll take this part. Okay. Second one, I'll take this one. Third. Then what about this one? It is also left out. This is also body. In the third time. So what happened? Body contains what here? Body contain statement and body. Terminal. So first time it executed begin, then statement, then again it comes to body, then this statement is executed, then this is body again. Let's take this one. First time it is executed this part, then this becomes body. Second time it is executed this part, this becomes body. Third time is executed, then it's a body, ending part, terminal. So every time it executed statement, then it goes back to body, statement, then it goes back, and then body becomes body, then it's null. So basically it is a recursive function. That's because it's a recursive function. Few more example is digit, which is nothing but unsigned integer digit. Now if you see unsigned integer, it may be plus or minus. Okay, unsigned integer may be plus or minus. Integer we call it as integer, we define them as integer, or we can see something other. And end part is digit. The same way here also statement are nothing but statement blocks. Block assignment statement are nothing but block. What do you mean by block? This is one. What do you mean by block? This is one. Break statement, continue statement, do statement, for loop statement, go to statement, if statement. These are all part of a statement. Yes, but and then it will end. Assignment means statement has to end. So there should be a terminal here. So basically, BNF says that, let me go through here. Basically, BNF says that what? Non-terminal is defined by token and non-terminal. Token can be divided at the end, it has to be terminal. So the programs goes up if statement defined by so and so. What is statement defined? If body. What is this body contains? Statements. At the end, it has to if end, correct? If end. So this part is there. So it is divided into parts, this statement. So BNF says that basic part is that on your left hand side, non-terminal, on your right hand side, there is a terminal and non-terminal, and we have to divide that into part. This is one part of it. Okay. Now let's move on to other one. Basically, this is one more extended Bosky normal form. Now, which was discovered by Nicholas. Sorry. It is also a form of syntax. What do you mean by syntax? Syntax is something that which you apply on a language. All right. If I write a syntax, let's take example. This is my pen. What do you mean by this one? Syntax is wrong. There should be a pen, or whatever the syntax is. Lecture, how are you? If I don't define this one, there's a syntax. So somebody else come and correct it. There are some difference. So on a particular language, there are some rules which you specify. He describes some rule. What the rules he described, Nicholas, was that star means what? Zero or more occurrence. Zero or more occurrence. Plus means what? One or more occurrence. Star means this one, plus means once. Question mark means zero or one occurrence. Question mark means zero or one occurrence. See difference. Star means zero, plus means one. Question mark means zero or one time occurrence. Use parenthesis. We can see with the help of an example which is already there in our next slide. Basically, if you go to the next slide, you can able to explain understand this part of it. Okay. Now other part, condition. Let's take example. These are the uses of E, B, and F. Correct? E, B, and F. These are something about E, B, and F. Okay, which is used. Definition is used by this notation. Okay, concatenation is used by this notation. Termination is issued by this notation. Alternation is used by this notation. Option used by this bracket. Okay, repetition is used by this bracket. Grouping is used by this bracket, and termination is used by this bracket. Let's take example. This is one example which we have seen it. I'll go back here. This is an example which says that A. See here, what is this? I'll rub this one. A. What do you mean by this one? A. Double string. What is double string here? Double string means what? Terminal. A or B terminal or C terminal or D terminal or E terminal or F terminal. G. These are alphabet digit. 0 terminal or 1 terminal or 2 terminal or 3 terminal or 4 terminal or 5 terminal or symbols. This is, what do you mean by double string? Close bracket, this one, characters, letters or digit or symbol, and ends with this one. And identifier, letter, or what do you mean by this? Repetition. It contains letter or digit or this one. This, what do you mean by this bracket? This says that these two brackets says that what? A repetition. Okay. Terminal, you just need to know what does it means. Okay. And these are the examples which we have defined here in this one. This is what EBNF says. On your left hand side, if you have an identifier, on your right hand side, we have an identifier. What identifier contains terminal or what terminals? Or close open bracket, this is a terminal, a right hand side, comma, combination of this one, comma, this one. What do you mean by comma? Means what? Concatenation of this one. Okay. Or this one right hand side or this one, this right hand side or this right hand, this one. This is what we have, a combination of terminals in this example. Okay, this is one example. So basically, if they ask you what do you buy, EBNF, or so you just need to explain up what is EBNF. Is nothing but extended Bosky normal form which were developed by Nicholas, and it is very often for regular expression which is used. Star means 0 or more times, plus means 1 or more occurrence, question mark means 0 or 1, and parentheses are is used for grouping. And then we can able to explain up with this one, the table diagram which we have gone through it. What is this? Definition is equal to concatenation, then there is a termination. All this comes here. If you see this one, these tables, we have defined this table, and you can give an example. Hopefully they can able to ask you. This is very important question. They will ask you about EBNF. They can ask you about BNF, and you can able to explain that with this one. Now next part we are going to see what do you mean by parsing tree. Parsing tree is that the how your statement, it says that how your statements are executed. It gives you the passing, how the values are being passed, how the values are being derived, how it is been executed. Okay, parsing tree. Passing tree or parse tree or passing tree or diversion tree is a representative that syntactical structure of string according to some context free grammar. Okay, this is a statement. For an example which I have discovered here, or I have given an example, Program which contains statement which contain variables is equal to expression a temp content. Let's take example. I have given a is equal to what is that? A is equal to b plus b plus constant. Okay. So I have written in a program. So program contains statement contain variable. This is variable. This come a, and then there is again term plus term. Then term becomes variable, and a plus become variable. This is constant. Okay. So I have written this format like this. An example of what actually parsing means. It's describe how your things are executed. How things are executed. Let's go to this one. Let's take example. I'm going to go for example. Sentence. Noun. If you see here, noun. If you see here, yes, I've got this. Yes. If I've got noun, verb, noun phase, sentence. Noun phase, article, noun, verb. This. The rat ate. The rat ate cheese. The noun becomes article. These are all sentence. How it is become means you are dividing your sentence into parts. A form of a tree you are defining. Whereas this, if you see the top one, we call it as a root node, and these are called intermediate node. That can be divided. Intermediate node. And this we call it as leaf node. We call it as leaf node. Remember that one? Leaf node, which is not divided. They cannot be divided. That is the last part of it. Start node, we call it as a root node. This part is called as an intermediate node. Sorry, this part, let me go through this one. This part will call it as intermediate node. This part is called it as intermediate node, and then this is called root node. Okay, based on this one we are going to see. So basically what we have gone through it, that we have seen something about, let me go through it, our what we have seen it, control A, cut, what we have seen it, let me go through. We have said BNF. What is the syntax of it? Am I right? And example of it. Then we have got EBNF. What is EABNF? Who discovered it? And what are the format for it? And we have seen some example. We have seen something about parse tree. Okay. We have seen some definition for it. Okay. And some example. But in the next class, what I'm going to see, I'll start with past example. Then I'll go to different part. Let's go to the syllabus. What is there in your syllabus? Look, we are going to see parse tree. We are going to see ambiguous grammar, because until I show you parse tree, I cannot go to your ambiguous grammar. Then if I show this one, attribute grammar is very easy, and then other part is that. Hopefully in my next class or coming to class, I'll wind up this one. Then I'll give you the notes, or I've already given you the notes. Plus I can give you the important questions of this one. I'll stop here and I'll see how things are going to